Now we continue with the PowerPoint. So this discusses the toolbar. If you go and see what you have on the toolbar, you have File Open, which will open the .pviz and the .text formats. We have Save As, which will save the current picture. Say you use that when you say read in the .text, and then you change a lot of the parameters and color it in various special ways, then you do a save. You can do a play, which is this thing here that rotates the plot gradually. We can do the select points by with this select button here to show the labels. That's the fastest way of doing labels. Here we can show only half the sphere. I must admit I've never used that option. We can reset the viewpoint, and we can select a custom origin. So this is reset, and this is select. This gives you back to the original viewpoint, and this selects a custom origin. As well as the toolbar, we have the sidebar, and we've illustrated the sidebar with various things. We showed you the color map. We showed you the individual clusters at the top. And then when you select the cluster, like here, you'll get its properties, and then you can change these properties. You can change the color, you can change the shape, that's the shape of the glyph, and so on. So, and there are these features like point size, which are true for all clusters. And then when you select a cluster up here, you can get a more limited set of capabilities, which are the ones you can change for individual clusters. Each cluster can, for instance, have its own glyph size. There's also the global glyph size if you want to increase them all by the same amount. So here's a couple of examples. This is one from generative topographic mapping, some oil flow data, which was in 12 dimensions and 1,000 points. And you want to find the clustering of these flows for each observation. And so when you do that, you then map it to 3 dimensions and use this generated topographic mapping, because this is a 12-dimensional vector. GTM works well when you have vector spaces. It doesn't work when you only have distances. You need real vectors. And so it gets a nice 3-dimensional representation. And you can see the structure nicely. If you want parallel generated topographic mapping, we have that on our site, but that's not the purpose of this talk. That will be a different talk to describe how to use that. And so when you do that, you'll get a structure like this, which shows rather a striking clustering. And this is on the basic screenshots and samples page. And what you have here is a generated topographic mapping runs using MPI in parallel. But I doubt if this program really needs to run in parallel. It just illustrates how you run a 4-way parallel version for this particular problem. Here's another example from a trading data. This is very old data from 1986. And this represents the amount of pairwise trade between countries. So this is not vector data, but this is a data where you have a distance, which measures the how much trade there is between the countries, where 0 means they presumably have a lot of trade, and 1 means they don't have much trade. And then map that into 3 dimensions. Here you can use we have a nice multi-dimensional scaling that you use, but for this small amount of data, you can go to the statistics package R, which has the so-called Smakov method, which is a very good approach to this problem. And here's how you get the R program from the one on our website. And here's how you actually run SmackUp for this problem. And then you can write out the data in a Plotviz compatible form. And that gives you some plots like this with we have the British Commonwealth at the green, so they actually look as though they have close connections. South America, orange, communist states. So this is, remember, this is a Cold War type, which are blue and that purple, and doesn't actually say what the blue points are. That's unfortunate. Let's just be lots of other things: USA, France, United Kingdom. It's a bit surprising the United Kingdom isn't near the members of the British Commonwealth. And here we have, because at least in some of them maybe because of the geographic location. So here we have Japan, USA. So this is actually pretty. The structure here is a little strange, and it's not so easy to interpret. Now we do. That's the end of the sort of technical discussion, and we will now go through some examples, starting with those oil flow and trading data examples, which have pviz files, plotviz files. Then we have a solvents example, which is on the Plotviz web page as an example. And then we have two examples from our research studying sequence data. So let's now do those examples. We should do 5. And we'll start off with the oil flow data. I say there's pviz and text. I will just use the pviz one. Say the text file you can also use. If you read in the TextViz file, if you want to use glyphs, you'd have to feed that in, and you'd have to also possibly change the coloring. And we have three classes of flow: homogeneous, annular, and stratified. And these observations, remember, in 12 dimensions, mapped to 3. So let's make this bigger. Again, we'll get rid of these measurable axes, and now we'll make it just pretty much bigger. You can see these are glyphs, so that's why it was a pviz file. It had glyphs to find, and so you can browse the structure. And we didn't set auto orientation. That's why they've become looking funny. We set auto orientation to true, so they will keep facing you. Otherwise, you will just see the sides of a funny two-dimensional shape, which won't look very good to you. And of course, we can come up here and look at homogeneous. That is a sort of, actually, I just removed it. I can get it back to you. And then come down here and maybe change it to a different color. Let's, what color should we have? How about a, where's a green? How about blue, green, and a purple? And we're changing the blue, so let's make, right now we can make it this color here. And so it's this bright orange brown color. And there we are. We can even, we can come to these green things here, and maybe we don't like them, so let's actually reduce their size. We now have a glyph size of 0.5. So you can see they do look small. So we've now made those ones small. And we can make the whole thing bigger if we want to look at more structure. So that's what we've done here. Now we're also rotating it by using our ordinary mouse and trackball, trackpad. and we're just dragging our finger on the trackpad, holding down the left mouse. If we do the right mouse, then we actually change the scale, so we can make it smaller or bigger. Let's keep it roughly the same, and that's the overflow data.